Hello everyone, Mike Silverman here. In this video, I'll show you how you can animate multiple different characters in Bevy, and you can select which character you're going to animate. I am going to be building this example up from the ground up, so if you just want to skip to the solution to that specific problem, you could skip ahead to the chapter in the video about that. But this is a problem that I struggled with for many days, and after a long time reading on the Discord and the documentation and even the Bevy code, as well as the spec for glTF, I have finally figured out how to do this um, based on actually somebody's GitHub solution that I read, which I'll definitely be crediting in the description. But anyway, here is the setup if you want to follow along with the setup. So first we are going to add the Bevy dependency, and I like to use the dynamic linking feature because it helps me compile faster. My computer is pretty slow, but this compiles pretty fast when you enable dynamic linking. And I add the op level 1 as suggested also in the Bevy getting started. We're also going to use this crate called Bevy Pan Orbit Camera, which adds camera controls. And it's just a nice way to move around in the 3D world and look at the models that we're going to be using. Next, we come over and we'll look at the app. So we've already done a few things here. We insert a clear color to change the background color of the world. And we put an ambient light in here so that we can actually illuminate the models and it's not completely dark screen when we looking through our cameras. Of course, we're using the default plugins as well. So the first part that I want to add is something for the characters to stand on, which is just going to be a flat square or otherwise called a plane. So to do that, we'll make a plugin to keep it nice and organized. So up here in the source folder, we're going to add the, I like to call it the level actually, because you could put more than one thing in here. But we're going to call this mod.rs. It should be unadded to the module tree, so we'll add it to the module tree. Make sure we save that over here. It just gets automatically added by the IDE nicely there. And we're going to get the Bevy prelude. And then we're going to be adding the plane plugin struct and implement plugin for that. And then we got to make build. So all we'll do is add a system that runs at startup. And it is going to be the setup plane system. Which is as of yet undefined, so we'll define that. This is going to take a few arguments. We need the commands so we can spawn an entity, and we need meshes because we want to spawn a mesh, which is going to be the plane. And we also want material so we can give the mesh a material. And that should be it for the arguments. Okay. Now all we want to do here is just spawn the plane. So we'll call spawn to get an entity, and we're going to use the PBR bundle. The mesh is going to be gotten from the meshes resource or assets. And that's just going to be a shape, which is a plane. And we want to declare the size to be, it doesn't need to be too big. Let's make it 50 meters. And we have to call into for some reason. I'm not a Bevy expert, but that's how it works. That's how you have to do it. We're also going to give it a material, which is going to be a color, which is some arbitrary color. I tried to make it green, so it would be like grass. But you can change the color just by adjusting these numbers. And the rest is going to be default. There's a problem because we didn't put the semicolon in. This is what, spelled wrong? Yeah. Okay, so now we have this plugin that's going to spawn a flat green square, and it's going to run at the startup of the app, but it's not going to run yet because we have to add this plugin to the main function. So we'll add plugins, and we called this the plain plugin. Should automatically import. There it is. Okay. Now, if we were to run the app right now, of course we wouldn't see anything. We have no camera. We have the lights, we have the thing we want to look at, but we don't have the camera. So we will do what we always do, which is create a new plugin for that. I don't know if I mentioned it yet, but I learned about all this organizing plugins from the Zymartu Games series, and it's a really great series, so I suggest watching that to get in the habit of these patterns. He's really good at teaching about Bevy. But anyway, here we are in the camera plugin, and we're gonna get the Bevy prelude as we always do. And we're gonna also use the pan orbit camera plugin that we included in our cargo toml. Let me include this in the module tree so I can get IntelliSense here though, first of all. Gotta save it. Let's go back. This should now autocomplete. Yeah. Okay. So we'll be using that in a bit. We're gonna set up the camera plugin struct. And we're gonna impl it for plugin. Impl plugin for camera struct. No, impl plugin for camera plugin. Got to do the build function. That's how you impl it. We're going to add a system. And it's going to run its startup because we just need to spawn the camera one time at the beginning. We'll call our system spawn camera. And we have to create that. All we need is the commands for arguments for that. And we're just going to spawn a camera 3D bundle, which is all the kind of stuff you need for a 3D camera all in one place. We are going to actually spawn it in a certain place because we don't want it to be at the 0, 0, 0 of the world. We'd like to be kind of up and away from the middle so we can look down at our creation here. So we'll specify the transform property. And you can use this handy method to just specify where you're going to be. So I used these values. To kind of be at an angle. And we will specify looking at actually, I don't think we need to do this right now. We'll see. We'll see what happens. I kind of forget. But the rest of this we'll put as default. Too many dots. Need the semicolon. Still too many dots. Okay. And so the way that this works is, whoa, not that. Let's go look at the pan orbit camera docs. So here we can see, maybe a little bit too zoomed in, that we have to add this plugin to our app, which we will do in a moment. And here is where we spawn the camera. We have already done this part, and we did a little bit differently. And then we have to add this pan orbit camera default in here as well. So we'll spawn an entity that has both these things in it. Okay, so first we have to make this a tuple argument for the spawn. And here we will add the pan orbit camera default properties. Finally, we will now add this plugin to the main function. Oh my gosh. Camera plugin. There you are. And then I think we can run this. Just use the small text. Hold on a second. All right. This is also the wrong folder. Oh no, it's the right folder. All right. Let's see what happens. I already built the app earlier, so we don't have to wait as long. All right. It is working, kind of. I cannot control the camera, so let's try to fix that. Oh, because I added the camera plugin, I have to also add the pan orbit camera plugin. Okay. You have to add both your own camera plugin to main as well as this. And in your own camera, you add that. Okay, that's how it works. Let's see. And they kind of overwrite. You can see before it was spawning the camera looking the way I wanted to, but the pan orbit camera does overwrite some of like what your camera's looking at and all that. So there is ways to like configure that. That is in the pan orbit camera documentation. But I think the way it is going to be good enough for our purposes at the moment. So that's cool. We can look at our green square. This is where we're going to set the stage for where we're going to spawn our characters. Okay, so we got our camera and we got our plane for our characters to stand on. Now we're going to load some character assets. And there's some different ways to do this. Well, there's two different ways to load from a glTF file, which is how we have to load assets. And if you look at the Bevy cheat book, here's the URL. We can see there's different ways to load. So you can load by label or by the master glTF asset. We are going to be doing this one. Let me show you the other one because a lot of the recent educational content uses asset path with labels. So they're saying it is less reliable, but maybe easier to use in some cases. This can be loaded immediately. Sub-assets are the different parts of the glTF file, like the animations, or if you have more than one scene. The disadvantage is that it will silently fail if you mislabel it, and you cannot address the sub-assets by name. So instead of accessing our animations by animation 0, animation 1, animation 2, so on and so forth, I would rather be able to say the death animation, the attack animation, so on. So we are not going to use this way, but this way may look familiar to you. Um, uh, so let's take a look at the other way. So if we have a complex glTF file, so then such and such, we want to be able to be flexible and navigate nicely. Basically, I want to load the things by name. So it shows how we're going to do this. And the one problem with this is that we have to wait for it to load. And there's no example about how to wait for it to load here that makes any sense. Fortunately, the Discord user DM Larry, hopefully I'm saying that right, provided some code that we're going to use to check if our assets are loaded, and then and only then we will try to use them by using some state changes. So let's go back to our code here. And we are going to create the asset loader folder in the source directory. And we're going to create the mod.rs. As always, let's save it. Let's get the error message. There we go. Let's add it in to our main. And now we can start programming here. So let's use the Bevy prelude as always. And we're going to define an asset loader state enum. And this is going to have a loading state and a done state. And we are also going to set a default state so that it will be the first state that is in existence in the app. So yeah, of course it will start as loading, and then once it's done loading, it will be done. We also have to derive several things here, so let us derive them. We're going to do debug so we can print things out. Default, so we can declare default state. Hash, I'm not sure why. Partial equality, equality, clone, and probably very importantly, states, because we want this to be states. Now, I couldn't tell you the reason for all these things. This is the code that DMLarry provided, and it works pretty well, so I just don't ask questions. Now, we're going to do the asset loader plugin next. And of course, we have to impl plugin. Okay. And here we first are going to add the asset loader state as a state that is possible to exist. And this is how you do that. And I'm guessing this could only go here if you derive state on the enum. Now, what is the issue here? Pub struct. We want to say pub struct actually. And let's semicolon that out there. All right. So we got some warnings, but we are going to take care of those. Next, we're going to add a system. And this is going to run on the enter of a state. So when this state happens, and it is one of the states we created earlier, the loading state, in fact. And when this happens, we are going to run the load assets system, which has yet to be created. So basically, this should be the first state because it's default. At least I believe that's how it works. And when it starts that state, which should be immediately when the app's created, we're going to try to load some assets. Okay, so let us figure out how to do that. We need commands. And we need the asset server. And let's just get that warning away. We get some more warnings. All right. In here, we can get a handle to the asset server, or to our asset. And we're going to load some asset here, which is going to be a glTF file. Now, for this, I'm using Quaternius 3D models here. The URL will be in the description, and these are some 3D characters that's for you to use by Quaternius. Excellent 3D modeler who gives away a lot of nice free models, good for testing games and stuff. And we're going to use this guy, the cleric. So you can download it, get the glTF file for the cleric, that would look like, whoa, nice picture. That would bring you to a Google Drive, and there's different subfolders. So you just go to the glTF, and you can download this one, and then you just put that into your assets folder of your project, which would be next to the source directory. So here we have the glTF file that we're going to use. We could see that it has a scene that is named scene. It has several nodes, and it has several animations, and the animations have names. And this is the animation we're going to use, the death animation. But there's also several other animations in here. So we'll load the whole file, and then we'll be able to be flexible about which ones we use. So let's go back over here, and we're going to load the cleric.glTF. Of course, you would rather convert this to GLB later on when you want to have more performance, because GLB is faster, but glTF is nice for our purposes now because we can actually look at the file and see things about it. It's more readable. Okay, with that being said, we've loaded this, or we're trying to load it, and then we want to insert a resource so that we can access this resource that we're loading. But to insert it, we kind of have to make a little wrapper around this. So what we are going to do is define an asset pack resource. And this is going to wrap around our handle to the glTF that we are loading. So this is a pub handle of a glTF, and glTF needs to be imported. So that automatically imported just there. Imported it just there. And here, let's see, it doesn't come in the prelude. Yeah, so here we are going to derive resource and debug. Why not? We could always debug it, print it out. It'll be nice. All right, what is this? Consider giving handle. It doesn't know what type it is because we haven't used it yet, but it's going to infer that in a moment once we use commands.insert resource. Not init resource, insert. And we're going to insert our newly created asset pack resource wrapping around the handle. And that should make that go away because it knows what it is now. It is a handle for glTF. Cool. So we'll have this, but it may or may not be done loading. So we have to kind of figure out if loading is complete before we start trying to access the different members of this glTF struct that we're going to have access to. So in order for us to do that, we are going to add another system. And this is going to be the check for load complete system. We want to do this on every frame. So we'll update, schedule it. We'll schedule it. We will put it in the update schedule. And we are going to check for load complete. But we only want to run this in the loading state because once we're done loading, it would be a waste of our system resources to continue checking this. So we are going to add the .run if, and then we'll pass the in state result of the in state function, which we will pass to that function the state that we created earlier, which is the asset loader state loading. And now we should only run this system in the loading state. Of course, this system has yet to be created. So we'll come on down to the bottom and we're going to create that system here. Now in the loading, check for load complete state rather, in the check for load complete system is what I mean to say, we're going to get a few arguments. We're going to get the asset pack, which is our custom defined asset pack. And this is going to be a resource, asset pack. We're also going to take the next state as mutable so we can change it to done loading if it is done loading. And as well, we will also, let me just format that so it's easier to read. Okay. As well, we will also take the asset events, which is an event reader, which to be honest, I have no idea what this means because I'm still pretty new to Bevy, but I can see what it's doing, which is it is getting an event about different assets. So these must be in the Bevy system somewhere, and if you're running the Bevy system as a whole, I guess, not the specific word system that means Bevy systems, but yeah, somehow we're getting an event that is telling us about assets, and we are concerned with the glTF type of asset event. So we'll see how that gets used, and it should make sense. All right, so here's how it's going to work. For every event in asset events read, which I assume gives you, iterates all over the events that the event reader has not yet seen. Cool. All right. And we're going to say if the event is loaded with dependencies, and then we're going to pass our asset pack the 0th member, which is the only thing inside of it, which is the handle to our glTF that we tried to load here. If that thing, clone the handle to it. Cloning the handles is cheap, so it's not a problem. So if we're getting an event about this, then that means it is done loading. So we can say asset loaded. Let's make it lowercase. I don't know why I like it more. And we will set the next state to done. So let's see. Looking good. So to review, we have two systems in this plugin. One of them is going to run when the asset loader state of loading enters, which should be at the beginning because it is the default. Then we're going to load the assets. Loading the assets involves getting the resource or the asset server, loading the Clark glTF file from our folder that we put it in, and then inserting the resource inside our custom wrapper, which is an asset pack, which is deriving resource, and it is a handle to a glTF. Then, every time the app updates, we're going to run the check for load complete only if we are inside the loading state. In the check for load complete, we read some events coming from, I'm not sure where, but we will get them. And we should get something called is loaded with dependencies for our asset pack handle, or the handle inside our asset pack. And that is how we will know we are done loading the glTF, and then we can set the state to be done. So let's see then. We now need to add this to main because otherwise it will never run. So let's go over to the main. We're going to add plugins, and this is the asset loader plugin. And now if we were to run this app, I would hope to see, whoa, oh no, what have I done here? Oh, right, I recognize this. Okay, I would hope to see this right there. So let me just save this one more time. And let's run it once again. Asset loaded. Cool. So we know that at least something is happening, but we would actually like to see a 3D model here. So let's go back. Let's figure out how we're going to do that. And what we are now going to do is create our animated characters plugin. And I like to put that in its own folder, animated character. And we do all the things we normally do when creating a new folder for a plugin. So we're going to add a system, of course, that when the loading state is done, we're going to spawn our characters. So we'll use the onEnter function here, asset loader state, that gets automatically imported, and done. So when this gets set to done, then we are going to call this, or we're going to run the spawn characters system, which has yet to be created. So let's create it. This is going to need the commands and the asset pack resource, which is our custom resource wrapper that we made before. We would also like our assets glTF. Okay, this is, of course, needs to be imported. Everything's fine now. So here we're going to check if our assets glTF is in existence. Or yeah, basically it should be, but we're going to make sure. This may not be necessary on second thought looking at this, but let's just press on with the demonstration and we'll see if it doesn't matter later. Okay, that's not what I meant to do, whatever that was. Back to it. So if there is a glTF inside, that is spelled wrong, asset glTF, then we're going to get our custom asset pack to get the handle of it. Okay. And then we're going to go ahead and spawn our character. It's a scene bundle. The scene is going to be the glTF. And here we're going to access the named scenes. We can do this because we loaded it in the glTF master asset style. And the name of the scene is scene. We know that because of looking at the glTF file. So if there's multiple scenes here, you can come in and look in the file and see what they are named, or maybe you named them yourself. Let's go back over here. We would also like to set the transform so we can set the location that this gets spawned. And we'll just go from X, Y, Z. And we'll just actually, this is the default values, but it'll be nice for when we copy paste to get multiple characters to just have this in here so we can change the transform's location. The rest is going to be default. So that's good. We need a semicolon. I wish it would be included automatically, but I don't know why it is not. Okay, so we should be spawning these characters now. Yeah, so this should actually create the 3D model for this cleric asset. So let's add it to the main app. This is called Animate Character Plugin. So we just created that. I believe we should be able to see that. Okay, so there it is. Not moving yet, but Pretty cool. Pretty cool. So next, we're going to have to load some animations from our file to animate those. So we would like this character to be animated, and to do that, we're going to go back to our plugin over here. Actually, let me turn this off so it doesn't destroy my computer in the background. Okay, so we want to animate our character, and to do that, we're going to create a custom wrapper for animations. We do that down here. So this is going to be called the animations resource, which is called animations. And this is going to be a hash map of string keys so we can name our animations. And they're going to hold, or they're going to map to a handle of AnimationClip. AnimationClip is the Bevy way of describing what an animation will actually change about something. Oops, I don't need to do it like that. I need to do that. Okay, so this is going to be a resource. So we're going to derive resource and debug. And this is going to be how we're going to access these animation clips. So now we want to actually insert these animations as a resource. Actually, you know what? I'm going to move this up here for my own preference because we're going to use that inside the spawn characters here. So inside spawn characters, we want to also insert some animation resources. So we'll come down here after we spawn the 3D models, and we're going to create an animations hash map. I think we will get the hash map not found error. Okay, so you can use whichever hash map you want. I'm going to use the Bevy one instead of the standard one because it's optimized for speed at the cost of security, but we're not really concerned with the security of these animations. What is this? Probably doesn't know what kind of hash map it is. Yeah. All right, so it'll know once we start inserting things. So we're gonna do animations, insert, and we're just gonna do a key of death. Death is the name of the animation, but is the name of the animation in the glTF file, but it's just what we're gonna call it. This is our own name. We could name it whatever you want here, but I would like to keep it the same name. And I would suggest to use an enum here so that you never mistype it, because later we're going to have to type this out again, and we could make a mistake, but we'll just type it for now. And in here, we're going to take the glTF asset, and we're going to access the named animations property. And since we use the master asset strategy for loading the glTF, we can actually do this instead of doing the index. And here we'll get the death named animation and clone the handle to it. All right, now here we've called it by name, and if we look over here, we have different animations. There should be the death animation up here. There it is. So all these names in your glTF file, you can find out what the animations are named if you didn't name them yourself. And this one has a bunch of different ones. We'll just do the death and the idle animation for now, but you'll be able to see that you could add as many as you want. All right, so we'll save that. We'll copy that. And we're going to also take the idle animation. So we have those inside this hash map here. And we're going to insert that as a resource. So we'll take the commands, insert a resource, and we're going to use our custom wrapper called animations. And inside that, it's going to wrap the hash map we just made. And now when we have other systems running, we should be able to access these as a resource. So the system we're going to create next is the run animations system. And for this one, we're going to take a query, a mutable query, to get all these animation players. We'll talk about what that is in a moment. So we'll get mutable animation player, and only if it was just added, because we don't want to continuously tell it to play animations. We just want to start them playing and have them repeat. Okay. And then as well as this, we're going to get our resources that we just inserted. So we can get the animation clips and we'll give them to the players and we'll say, animation player, please play this clip for us. Okay, so where are these animation players coming from and what are they? Animation player is created at the same time as a scene is created. And when when scene is created, it gets a player somewhere inside of it, which is kind of hard to get to. But for right now, that doesn't matter. But when we want to animate specific characters, it will matter. So all we got to know right now is that a scene, when it is spawned, it creates an animation player with it. Okay, and that we can use these animation players to play an animation on those scenes. So right now, we're just going to loop through them. So there's only going to be one because we only spawned one scene, but we'll just loop through all of the one that there is only one of. And we're going to say for that animation player that we want to play an animation. The animations we get from the resource that we set up, which is the hash map of animations. So in animations 0, because it's a tuple struct with one thing inside of it, we're going to get death. And this is why I was talking about making enum for your keys, so that you don't ever misspell it, because we're going to call expect here. And if you misspelled it, you'll panic here. So we expect animation to exist here. And then that'll be a handle, and we'll just get a clone of the handle. I don't know why we call clone weak, but you can read about clone weak and what it does. I'm guessing we just don't care if the handle to this animation in this instance would disappear, that we would delete the animation. Because the way I understand it, it works like RC, reference counted. Anyway, I think that's a bit off track right now. So will work. Now, if we do this just like this, it will only play the animation once. So we want to actually repeat it. And you can also do a lot of customization. You can set the speed. I like to set the speed a little bit lower for this particular animation. And now we have to add this system to actually run the animations. So up here at the top, we're going to add another system. And this is going to run on update. And we're going to run animations. And we're going to see that this shall cause an error. What have I done wrong? Remove the extra argument. Add plugins. That's not what I meant. Add systems. Okay. So here we should see an error. Let's see if you guess what it is. That's right. Run animations does not exist. No, the resource requested by run animations does not exist. Because remember, we are loading our glTF. It takes a minute and then it changes the state to done. So we have to only run animations in the update schedule if the uh, in state loading state is done. Oh, I imported the wrong thing. Run if in state loader state done. Okay. Now we should be able to see animation going. We do. That's very exciting. But there is a problem with the way we're doing this, which is what we're about to see. Let's see what happens when we add a second character. To add a second character, we can just go back down to spawn characters. We'll find where we spawn a character, copy that, paste it, and we'll change its position so that we can see that it's in a different location, so they're not just inside of each other. And let's go back. Let's run it. We should have two characters now. And they're both animating, which may or may not be what you want. What I want to do is choose only one of them to animate. And how to do that was the reason I created this whole video in the first place, because it was pretty hard to do. But let's see how we could do that. Okay, so why this is happening is because of the animation players and how we're telling them to play. When these scenes are spawned in, they each get their own animation player, and telling that animation player to play a clip will play that clip onto that scene. So that is how you animate a certain scene and not another one. But how do you get a hold of that particular scene or that particular scene's animation player? How are they linked together? That is the problem we need to figure out. Because if we look down here, we are looping through all the animation players, and that will be two different animation players. And we can see that if we print out once for each loop. Since there's two scenes, there should be two animation players. There, you could see that. Now, how do we link these animation players to their scenes and kind of select one or the other? Well, you might think something like this. Instead of just spawning the scene bundle, we'll spawn a scene bundle with some sort of labeling thing. We call this player character name. Uh, and we'll say player 1. Now this doesn't exist yet, so we will create that here. And this has to be a component. And debug, why not? To string, or not to string. Okay, so now we will have it like this, and let's do the same to this one so we can distinguish them. Oh no, it's all falling apart. Okay, that should work. Name it player 2, of course. So then you might think, okay, we will query something like this, where you get an animation player and a player character name as well, because they're kind of on the same entity, right? But this actually does not work. We'll show you this, that it's not going to animate at all. This is a problem. I think you have to do it like that. Yes. And now in our query, we have two different things. So we have an animation player and a name, player character name. Let's make it more specific. Let's print out this. This query is actually not going to find anything, is my prediction based on my experience. We should see no print lines here. And in fact, we don't. So that is because they're not on the same entity. The animation player is not inside the entity we spawn, or rather it is deeply nested inside of it, inside of the scene. Because when we spawn this entity has a scene and it has a character name, but it doesn't have an animation player on this entity that composes these two things. The entity that has the animation player is a child of the scene somewhere inside of its tree of children, which could be a lot of different things. So we have to somehow create a link between this entity here and the animation player that is inside there. Okay, so to do that, we're going to use the solution on this GitHub question that was posted that had basically the same question, which is how do you control which animation player is playing? And Pinkponk suggested this solution, which turned out to work. And basically what they do is they look for all the animation players that are in the world, and then they find the parent entity for that animation player, and then they find the parent entity for that entity, all the way up until they finally get to the topmost parent entity, and that entity would be the one that you created your scene on. For us, that is this entity that we spawn here in the spawn characters entity, so it would end up being this one because the animation player is a child of something inside this scene. Once we get up there and find this entity, we're going to add another component to that entity programmatically. That's going to be the animation player link, and inside that will be the animation player entity. But we can't just type it in here like that because at this time when we spawn it in, we have no idea what entity it's going to be. So that is why we use the code that's provided here. And I copied that code into another file. This file is next to our main file for this plugin, and it's called link animations. Inside this function, we got three main things. First, we have our animation entity link, which is a component, and we're going to use this component to hold an entity, and that entity is going to be the entity with the animation player. We have to find that entity. So to do that, we have the getTopParent function, which takes in the current entity. The current entity is at first going to be an animation player entity, but we're going to mutate it inside the function to find the parent, and we'll replace it with the parent continuously until we get to one that has no parent, and that would be the top. In addition to that, we'll take in all entities that have parents, which is just a query to anything with the parent component. Things only have parent components if they have a parent. So inside here, we'll loop, and we're going to see if inside all the entities with parents that the current entity exists, which means this current entity has a parent. Since it's starting out as an animation player entity, we know it would have a parent, and then we'll just take the reference to that parent. So then we're going to take our current entity and we're going to replace it with the reference to the parent. And then we'll run the loop again, and we'll see if this new entity also has a parent. If it does, we'll replace the current entity with that thing's parent. Eventually, there won't be a parent because we'll be at the top, so we'll break out of the loop, and then we'll return the current entity. And that current entity will be this. Okay. So what we use this for, what have I done here? I think I accidentally undid a change there. Okay, so we have the ability to get the top parent of some entity. We're going to use that inside the link animations system. The system takes in a few different arguments. First, we're going to query every single entity with an animation player. Just take the entity for it. and it can only be an animation player that was just added because we only need to link it once. Right when it gets added to the world, we link it, then we're done. We also want to get all entities that have parents because we're going to use that in the function we showed above to find the topmost parent. We're also going to look at all the animation entity links that already exist because there can be an issue with putting two animation entity links on the same parent. I believe that's because entities can only have one of each type of component in Bevy. Okay. Then of course, we have the commands because commands are going to be how we insert the entity link component into the top parent. So we start off with a loop here, and we're going to loop through every animation player entity that there is. And then we're going to find the top parent for that animation player using the getTopParent function. And then inside or with that entity, we're just going to insert the animation entity link. And that is going to be a reference to the entity of that animation player. So now this would be like it was in here, except that we would never be able to type this because we don't know it at the time that we create this, the time that we type it out. Okay, so then that should create all our links, and then these entities would all have links to their proper animation players, and we could query for animation player link and player character name, and we could say for all of those things we queried, if it has player number 1 as its name, then play the animation. So that's what we're going to do. So here we're going to add another system in here. So to add two systems, we have to make it a tuple. So we'll add another system. And this is link animations, link animations. And we don't write the function though. We are gonna see. We only want to run this in the state of the asset loader state done. So this should link all of our animations. Okay. Stand by. Oh, you gotta run if. Should be good. Okay. So now we'll have all these links inside of our entities here. And then we can use those links inside of run animations. So instead of just querying for all the animation players that exist, we're gonna use our links. So let us instead do it like this. Well, delete this. And this should still be the original query that gives all animation players. We still want the resource for animations, but we're also going to add in this. So first we'll take the player character name components and the animation link, animation entity link component. And we only want the most just added animation entity links. So now we have all entities that have both a player character name and an animation entity link, which should be any of our characters here because we added the links to them using the linking function. Then we have to change this. So first we're going to loop for the player character query. And that's going to give us the character name and the animation entity link. And if there is an animation player inside the link. So let's say if there is the animation player. Let's just comment this out for the moment. We have a problem with get mute. I think I need to declare something differently. Oh, the query, not the link. All right, so if there is an animation player inside of all the animation players that we query in the world, that is the entity that is inside our link that we stored the link, the entity which is over here. So we use this to look it up in all of the animation player entities. Then we can use that animation player, or first we can check if it is the right name. So if player character name, and here we're just going to type it out, but could get a better system for this. So if it's player 2, then we will play it. So take this. What's the problem here? Oh, this is .0 because the player character name is stored in a tuple struct. Okay, so we can compare that. If it's player 2, then and only then will we play the animation, and that should work. Let's find out. I don't know why. Let's find out what I did wrong. We see that it links the entities to the animation player entities. Okay, I'm pretty sure I was not supposed to add this line because these would have already been added. Uh, yeah, so, or when they're added, they won't be linked, is what I mean. So that was my mistake. Hopefully you caught that. And now I can delete these print lines. Been debugging it for a few minutes here, but I think that should be it. Let's see. There you go. So we got to choose which one we're animating. Let's see if we can animate the other one into an idle animation. So we can just play two different animations. That would be pretty cool. So let's do player character 1, and we'll do idle. Well, while I'm up here, I can clean up that. What have I done? Okay, that looks fine. Let's see. Yeah, you can see he's idling. See his little hands moving? So we got two different animations playing, two different characters spawned out of the same glTF file that holds all the animations. You only have to load the glTF once. You can spawn multiple characters and control their animations. Yeah, took a while to figure out how to do this. Multiple days researching on the Discord, eventually finding that GitHub post. But here are the results. Beautiful. I do wish it wasn't like this and that there was a better way to target animations to different scenes. If there is a way that's better, I wasn't able to find it in a long time of researching, but yeah, hopefully a better way is revealed soon. But until then, feel free to use this way. Hopefully that was helpful to you. And I will put the code on GitHub. And once again, thank you to the solutionist, Pink Punk, and everyone else who helped me on the Discord discussing the problem. From here, I would suggest the videos by Indiedevcasts YouTube. He did some video about how to change between different animations on a character. So that would be the next thing I would watch if I hadn't already watched that and I was watching this. But with that being said, hopefully this was helpful. This has been Mike Silverman from the Snowden YouTube channel. Have a great day. Goodbye.